which HTTP client should you actually be using? Yeah, if you're working with Spring, I bet you've stared at your screen and asked this exact question. The choices have changed over the years, and honestly, it's created a lot of confusion. But that's what we're here for. We're going to clear all that up. We'll walk through the whole story of these clients, figure out what each one is really for, and nail down which one you should be reaching for today. Okay, so let's rewind and start at the beginning. We've got to talk about the classic RestTemplate. For what feels like forever, this was the tool. It was the reliable, go-to, synchronous client for pretty much everyone in the Spring world. This thing has been around since Spring 3.0. It's a seriously powerful tool built on what's called the template method pattern. You've probably used its methods, right? Stuff like get for object and post for entity. And while it was super configurable, well, its time has come. It's now officially in maintenance mode. And the Spring team isn't being shy about it. They've made it crystal clear. RestTemplate is on its way out. This is a big deal, and it really signals a major change in how Spring thinks about this stuff. And this slide just lays it all out, doesn't it? It perfectly shows the difference in style. Over on the left, you've got the RestTemplate way. Everything is just kind of crammed into one big method call. But then look at the right. That's the modern Fluent API. See how it reads almost like a sentence? Get, then URI, then retrieve. Each step is its own clear, readable part of a chain. And that focus on readability, that's a huge clue as to why things started to change. So what caused this move away from RestTemplate? Well, it was a massive shift in how we think about programming, specifically the rise of reactive systems. And that big idea led directly to the next client in our story, WebClient. And at the heart of that reactive shift is this concept, non-blocking I/O. Think about it. In the old traditional blocking way, when your code makes a network call, your thread literally just sits there. It waits. It's stuck, doing nothing. But with non-blocking I/O, that thread is immediately freed up to go do other useful work while it waits for the response. What does that mean for you? It means a tiny number of threads can juggle a huge number of requests all at once. It's just insanely efficient. And that brings us right to the core purpose of WebClient. When it came out in Spring 5, it was built from the ground up for one thing, Spring's reactive stack, which is called WebFlux. So it's asynchronous by its very nature, and it uses that beautiful Fluent API we just saw. But, and this is a big but, here's the catch. You can technically use it in a normal, old-school Spring MVC app, but it feels like a hack. You have to call .block at the end to force it to wait for a result. And you have to drag in a bunch of extra libraries like WebFlux and Project Reactor that you might not otherwise need. You can see that Fluent API in action here, and it's super logical, right? You say the method you want, you define the URI, you tell it to go get the data, and then you handle the response. It all makes sense. But look closely at that last step, step 5. If you're not in a truly reactive app, you have to slap that .block call on the end. And what that does is it forces the whole thing to stop and wait, to behave synchronously. Which, when you think about it, is pretty ironic. You're using a non-blocking client just to block it. It kind of defeats the purpose. Okay, so this awkward situation, using a non-blocking client in a blocking way, is exactly what led to our next stop. And this is the one you really need to know about today. RestClient. This is the modern, recommended solution for most of us Spring developers. So pretty recently, in Spring 6.1, they introduced RestClient. And the Spring team is calling it the official, modern successor to RestTemplate. Its whole reason for existing? To solve that exact problem we were just talking about. It's all about giving developers that slick, modern API without shoving the entire reactive programming model down their throats. So if there's one thing you take away from this, let it be this. RestClient gives you the best of both worlds. You get that clean, readable, Fluent API from WebClient, but it works perfectly in the synchronous, blocking world of Spring MVC that most of us are used to. That means no more .blocking calls and no more pulling in extra reactive libraries you don't need. It is, without a doubt, the new standard for synchronous API calls in Spring. And the best part? The Spring team made moving over from RestTemplate super easy. I mean, look at this table. It's pretty much a direct one-to-one translation. What used to be a single chunky get for object call is now just a nice clear chain of get, URI, retrieve, and body. Honestly, updating your code is a simple, almost mechanical process. It's not a huge refactor at all. Okay, but it gets even better. Beyond just making these direct calls, Spring gives us an even cleaner way to do this, a higher level of abstraction. We can actually define our clients using simple Java interfaces. And let me tell you, this is a seriously powerful pattern. This code snippet right here, this is the before picture. This is what it used to look like. Inside your service class, every single method, whether it was get by ID, get all, or add, meant you had to manually build the entire request. You're setting the URI, specifying headers. It was just a mountain of copy-pasted, repetitive boilerplate code. A real pain. But now, look at the after picture. What a transformation. By defining a simple interface and sprinkling in a few @HTTP exchange annotations, all that ugly boilerplate just evaporates. Your service layer becomes incredibly clean. All it does is call methods on an injected client interface. And all the messy HTTP details, the URLs, the HTTP methods, the path variables, they're all neatly tucked away, out of sight. I mean, the benefits here are just huge. You slash your boilerplate code, you get a clean, central place that defines your API contract, and your code becomes so much easier to read and maintain. And you know what the coolest part is? This pattern isn't locked into just one client. It's supported by RestClient, WebClient. You can even use it with the old RestTemplate if you have to. All right, so we've taken a quick trip through the history of Spring's HTTP clients, from the old to the new. So that brings us to the big question. How do you make the right choice for your project right now? Now, before we give the final verdict, we have to talk about a little debate happening in the community. It's a bit nuanced, but it's important. As this quote points out, developers who've used other tools like Feign are used to this really slick pattern. They define one single Java interface with all the annotations, and then they could use that same exact interface for both their server-side controller and their client-side code. But with Spring's approach, the new @HTTP exchange annotations for the client are different from the @request mapping annotations on the server, so you can't share that contract anymore. And for some developers, that's a real point of friction. But putting that debate aside, for the vast majority of projects out there, the official recommendation from the Spring team is refreshingly simple. You ready? Here it is. If you are building a reactive application on Spring WebFlux, you use WebClient, period. If you're like most people and you're using the traditional servlet-based Spring MVC, then RestClient is your new best friend. That's it. That's the modern standard. And that really leaves us with one final thought to chew on. This whole evolution from RestTemplate all the way to RestClient proves one thing. The Spring team is definitely listening to developers, and they're constantly trying to make their APIs better. So the big question is, what's next? Will the next big evolution finally solve that contract sharing debate for good? Will we get a way to truly unify the client and the server definitions? I guess only time will tell. Thanks for tuning in.